Hello everyone, my name is Luke, and today we're going to be talking about memoization, an optimization technique. So today we're going to go over what memoization is, why it's useful, and eventually how to create our own memoized functions. So through our developer careers, we will be encountered with programs that will often waste time by calling functions which we calculate the same results over and over again. Let's take a look at one infamous problem that surely bottles things up. That's good old Fibonacci right there. So this recursive function calculates the Fibonacci of n, and in order for it to do that, it has to calculate the Fibonacci of the previous two numbers. And we can see how quickly, as n increases, this gets pretty heavy. So let's visualize this for a second. So this is a tree graph of Fibonacci of 6, and as you can see, this is how it's broken down and calculated. Now, if you can quickly realize, there are a lot of repeating calculations to get to Fibonacci of 6. So those are the repeating functions. There are quite a few, and really what we would want to do now with a memoized function is to calculate everything once, store the result, and then when it needs to be called again, just retrieve it from the cache, we'll call it. So just for a little demonstration or a thought, Fibonacci of 50, if I were to say it would take 40 million recursive calls, would you bet higher or lower? I'll let you guys think. All right. We have our answers, our bets? That's right, over 40 billion recursive function calls to get fib of 50. So first, let's describe memoization for a second. It's an optimization technique used to speed up computer programs by storing the previously computed results of expensive function calls and returning the cache result when the same inputs occur. Beautiful. So this is what a memoized Fibonacci function would look like. As you notice, the memoized part is a higher order function. It has its cache, and what it returns is the actual Fibonacci. The bottom part will look similar. It's the Fibonacci sequence, but right before it does a simple check of, for whatever input it is there a cached result? And what the memoized function does is it will take the parameters, right, that's given in, and it will use that to index the cache. If the data is present, it will be returned. Otherwise, the function is executed and the result added to the cache. So at the bottom, we run it on fib of 6, and this is our result. So I've added a couple console log statements just for us to see what's going on. But if you notice, first two are saved, and then it's pulling from the cache. Great. Now, just for a little fun, let's take a look at what a memoized Fibonacci of 50 would be. So what I've done is I've added a counter up top to keep track of all the actions that we take, just to see how many calls does it take to calculate this. I'll let you guys make your mental guesses. Let's see. So we see this took 99 compared to over 40 billion. That's right. Pretty amazing. Pretty amazing. Now, why does this matter in a way, right? Why is this such a big deal? And really, it comes down to optimization and performance. Are those just buzzwords? Let's see. So, in 2016, a company owned by Google called DoubleClick, they do mobile sites, and what they did was they released a study for mobile publisher revenue stuff, and they found some pretty interesting facts of performance and speed. So first, it was that the average time of mobile sites load time is 19 seconds over 3G. 53% of the studied mobile sites were abandoned if it took more than just 3 seconds to load. And so comparing to 5 seconds to the 19 seconds observed, we realize there's some differences. The biggest one being the 70% longer average sessions. You know, you retain people want things quickly as possible, and really at this point in time, that's what we have to deliver. Okay, now we're going to take a look at how to write our own memoized functions. So as I said before, this is a higher order function, and really the key is it's taking in something. Once it's first calculating, it's going to check, has it been calculated? If not, it's going to store it. If it is, it returns it. So if you follow along, we have an outside function that's a simple add 10. It takes the number and it adds 10 to it. We're plugging it into, it's getting wrapped with the memoized function, and it will be the result of, the calculated result is going to be the result for the stored cache function. So if we run it on memoized add 10 with 10, the first time it should save it, calculate it, and then save it, and then the second time it would just be grabbing from it. And it's just demonstrated right there. Okay, and just some things to remember. Memoized functions are higher order functions, but also the functions that go into this memoized function should be pure, as in the input it takes should always return the same output. Because if we have any type of mutations going on in there, it would really defeat the purpose of storing the result for that input, right? It's got to be pure. And lastly, you are giving up some space for speed, but if it was our way, we'll take speed for some space, because we're always fighting against time. And then, also, while this is pretty impressive stuff, a lot of times, if you don't really need to do this, don't. Keep it simple. Use this for big functions that really you'll see a big change in it. And that's my presentation. I hope you guys enjoyed it.